Good evening, children. Welcome back to our class of SAT mathematics. So we were in data interpretation, so we are continuing with the data interpretation now. So let's see what we have to do. We have done 2 classes on data interpretation and this will be the 3rd class. So you all know, like, data interpretation is nothing but some statistical analysis, that's all. Okay. So now look at this. Which of the scattered plots below show a negative association? Negative association A, B, C and D. 4 are given. So you can see these are all positive, negative 1, 2, 3, 4, 5, 6, 7, 8 and negative 4. So our answers are A, B, C, D. A and C show positive associations, D shows no association. So what is that? A and C show positive associations. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And A and C. D shows no association. See, how are they associated here? So children, these are scattered. So if you look at the plots here, you are showing, you are seeing the balanced part of it, and the positive side will be higher than the negative side, and C has equal balanced thing on both the sides. So, and positive things are higher, the values on the positive side are higher. So we could have been more comfortable if the values would have been given numerical values, but still by observation you can tell A and C have positive association, and D, of course, it's a non-associated because they are scattered very haphazardly. There is no association at all here. So the only option is B. The only option is B. So please note it, children. Please note this graphs. Fast, children, quick. C, D, please note that C and D. Yeah, so let's go to the next page. Please note it fast. Right, children, so let us go to the next question. So look at this. The scattered plots at the right shows the prices and weights of various boxed products of the 5 labeled products which has the best unit price. So now weight and price, he has given units A, B, C, D, which has the best unit price, he says. So scattered plot at the right shows the prices and weights of the various boxed products. Of the 5 labeled products, which has the best unit price? So you see here weight, so if you take unit price, it is total price by number of units. See, if I spend 100 rupees on 10 units, then what will become unit price? 100 by 10 units. So that is 100 by 10. So that's what total price by number of units. That is what we need to look at. For each of the 5 points on the graph, product B has the lowest price to weight ratio. Therefore, product B is one of the best price units. So look at this. See, the weight price is this, and by weight, price by weight. So this is the price by weight. This is price by weight is much higher. The price is same, almost like B, but the weight is much higher than B. So when with higher value, if you divide, the overall ratio will become smaller. See, you see this is little higher, but this is almost double that. So here if we would have mentioned the values, we would have been able to tell accurately. Definitely in examinations they will give you the values also. So here we are going with little bit of imagination. So therefore children, so if you take the ratios of prices to that of weights, you are getting B as the best unit price product. So option is B. Please note it fast, quick. See, price should be greater and number should be lesser. Wherever this happens, the ratio will be greater. Right children, greater means I am showing by greater arrow, and smaller means I am showing by lesser arrow. So that's what happens. So if you look at the graph, you can take approximate values and you can tell me, okay. You can take approximate values and tell, okay, best price, where you get it, okay. So let's go to the next question. Question 3 and 4 refer to the following information. The scattered plots above shows the average scores of 10 golfers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. So this may be best fit line, this may be best fit line, 10 golfers and their weekly practice times. Average scores by average practice time per week means, for example, this is best fit line. So what is that average score he is having? 80, 81, 82, 83, 84, 85. So 2 units, 82, 84, 86, 88, 90. So this is at 88. 88 by 12 is the best fit line we are getting, means average ratio if I take, okay. But anyway, what he is asking, let us see, and then we will conclude what has to be done. What is the average score of the golfer that is farthest from the line of best fit? So options are given as 93, 96, 98, 99. So this is the graph, we have. So farthest, what is that he said, what is the average score of the golfer that is farthest from the line of best fit? Farthest means like if you take vertical distance, this is farthest or not? So what is its average score? This is 98. So option C satisfies, children. Option C satisfies, okay. So this from best fit line, the distances are smaller. This is very small, next smaller is this is the longest of all. So therefore I will take that as the value, and this is 98. That is 98, right children? So please note it fast, quick. See, always in these type of problems there will be a best fit line. This is the best fit line. Okay. Next, let us go to the next question. Fourth question. There are two golfers whose average practice time is the same. Whose average practice time is the same. What is the difference between their average scores? I don't know. Let us see whose average scores are same. Whose average scores are same? No. Let us see the question once again. There are two golfers whose average practice time is same. Sorry, not average score. So, practice time. Which two have the same practice time? These two. These two have the same practice time, children. So, one is 100 and the other is 90. One is 100 and other is 90. These are the two people who have same practice time. You see, practice time. Draw a vertical line on the practice time vertically. You will get the same practice line. I mean time. Whoever are on the same line. Okay. So, if you take this person and this person have same practice time. So, the difference of their average scores is 100 minus 90. 100 minus 90 is 10. So, it is option D, children. Okay. Please note it. See, for every time of this type of problems, we need to go back to the question and then look at it. So, up and down movement will be there. So, in this up and down movement process, you should not lose the focus or concentration. Your question reading should be accurate, and application of the concept should also be accurate. But of course, in examination, you will have a question paper in front of you and graph will be there in front of you. So, this type of wastage of time will not be there, children. Don't worry about it. Okay. Please note it fast, quick. Right, children, let us go to the next question. According to the line of best fit in the scattered plot below, which of the following best approximate the year in which the number of cars repaired by J Motors was estimated to be 4,500. This is horizontal line is number of cars repaired, number of cars repaired, and this shows average scores. This shows average score. So, what is that he is asking? According to the line of best fit in the scattered plot below, which of the following best approximate? See, this is the line of best fit. This is the line of best fit. Approximate the year in which the number of cars repaired by J Motors was estimated to be around 4,500. 4,500 is somewhere here. So, this is the thing. 4,500 cars. This is 1990, 1995, 2000. So, it should be somewhere around 1996. So, what are the options given? Approximately it is 1996, children. So, option A satisfies, right? I think you have seen that graph. See, this is 1990, 1995 and this is 1996, approximately 1996. So, therefore, option will be option A, which is 1996, 4,500 he said, isn't it? So, look at this 4,500. Right, children? So, please note it fast. Take this page 1, then we will go to page 2, quick. Right, children? See, in these graphs, Identifying right positions are important, for that the values are important, children. The first two questions values were missing, so we were taking approximations and we were trying to tell, but here onwards you see we find values, so we can tell accurately. Okay, there it is approximation, here it is accurate. So in statistical analysis sometimes approximations are also accepted, right children? So certain times we'll have approximations and certain times we have accuracies. So both are accepted, but when I talk about approximation it should be very near to the original value, right? So now let us go to the, I think this you have to copy, quick children. So right children, so let us go to the next question. So let us see what is there. Question 6 to 8 refer to the following information. This is high temperatures and this is low temperatures. This is the line of best fit. That is the line of best fit. Only one point is there on the line of best fit. Only one point is there in the line of best fit, on the line of best fit. Okay. 1, 2, 3, 4 are below and 3 are above. Now let us see what he is asking and what we need to do. The graph is a scattered plot with 8 points each representing the lower temperature and the high temperatures of 8 days in a September in a certain city. Both the low temperatures and the high temperatures are measured in degrees Fahrenheit. The line of the best fit for the data is also shown. Based on the line of best fit for the data shown, how many degrees does the high temperature increase when the low temperature increased by 1 degree? Low temperature is increased by 1 degree, how much increase is there in this one? So now this is 1 degree increase. Where are we finding? So this and this maybe. So this is 65 and this is maybe 66. That may be 66. So what is the increase in temperature? This may be 81 or 82. So if this is a graph paper, we could have got approximately. This is 76. Then 82 minus 76 is 6 approximately. Just a minute. This is 75, 76 and that is 82. So 6 degrees approximately. So otherwise, so this is 66, that is 70. So low temperature is increased by how many units he said? When the low temperature increased by 1 degree, what is the increase in temperature in the high degree? I mean higher temperatures. So now y2 minus y1 by x2 minus x1. So when x2 minus x1 is 1, then what is y2 minus y1? 76 to 60, and that is 90 to 70 using the approximate values found along the line of best fit 60, 70 and 76, 90. The slope can be calculated by this. So, where are the values we are taking? 60, 70 and 76, 90. 60, 70 and 60 degrees is here, low temperature, and high temperature is it is approximately 76. Then high temperatures are what? 60 to 65. Then it is 90. This is 90 at 76, and at 76 it is 90, and at 60 it is 70. Means there should be, this line should have been here. There is some point mistake. So, what is the ordered pair here shown it as? This is previous question. So, temperature increased by 1 degree. The ordered pairs, where did he show the ordered pairs for us? Yeah, using approximate values found along the line of best fit. So, these are only approximations, children. So, there is some value, but anyway, looking at this, we will take at 60 it is 70, lower temperature is 60 and higher temperature is 70, we will presume. Similarly, here 76, 90 is correct, but here there is some doubt because that values might have been a little bit here and there. So, approximate value only we are getting, not exact value, but still we will take approximate only, as we are not able to get exact values from the, we are not able to figure out exact values. So, y2 minus y1 by x2 minus x1 is the slope, that is equal to 1.25. Okay. So, 1.25, is there any value near 1.25? No. So, the nearest value to 1.25 is 1.3. So, therefore, please note this question. I think children, you have to take this one screenshot, because I cannot wait for you copying so many things. So, please take a screenshot quick. Fast children, quick. So, did you take the screenshot of it? Let us go to the next page. So, please note this screenshot also quickly. Finished. So, let us go to the next page. Take screenshot quickly. See children, if you remember, we discussed the slope is nothing but the amount of height raised when you travel through a unit distance horizontally. So, that is actually the definition of slope. So, he said lower temperature increases by 1 degree means it has moved by 1 degree. What is increase in y value? That is what we need to see. So, that is nothing but slope. Okay, children, that is what we have taken it here. Quick. Slope we have taken, we got 1.25. So, value somewhere near to 1.25 is 1.3 in option. So, therefore, we will take it as 1.3. We may not get exact value, sometimes approximations are accepted, children. Okay, please note it fast, quick. Right children, so let us go to the next question. So, what is the predicted high temperature of the day when the low temperature is 58 degrees? Again we should go back to the graph children. So, when you go, I mean when it is 58 degrees, the approximate value which is closer to 78 is 68 degrees. So anyway, let us see what is that. He said 58 degrees, isn't it? So when it is 58 degrees, when it is 58 degrees means approximately 60 you will take, which is 76. So 68 we are getting. What is the predicted high temperature of the day when the low temperature is 58 degrees? 55, 58 is somewhere here. 58 is somewhere here. So what is high temperature if you proceed? Let us see. So it should be going like this, approximately 68 children. This may be 68, okay. Best fit line, on best fit line we should take, isn't it? At 60 it is 70, at 60 it is 70. So next at 58 it is 68 approximately. So whatever temperature he says at that place, we will take vertical lines. At that place we will take vertical lines. You see 60, 70, 76, 90 also. 60 means if you draw a vertical line, it is touching best fit line at 70. So 60, 70 is accepted. Then next what is that? He said 76. 76 means here. 76 if you take, it is approximately, it is touching 90 degree. You see 90 degree like that, right children? So best fit line, it should touch the line whatever you draw, it should touch the best fit line. So therefore this is valid, and afterwards even this is valid. Approximately we are getting. So we may not be sure, because if that would have been a graph paper, we would have got exactly what is the value. So approximately at 58 it may be 68, 68 or somewhere near to that. So we will take approximately it is 68 children, okay. Please note it fast, quick. There is lot of difference between identifying using a pure graph paper and imagining drawing our lines, because our lines will never be straight, they will be zigzag. So therefore it does not matter children, approximately you take, because you cannot draw a straight line, or you use straight scale and draw and then come to exact conclusions, right children. So because I am using normal pen, horizontal and vertical lines, that line may go curved. So definitely you may get few units that side, this side, does not matter, okay. Next, let us see, among the 4 days marked 1, 2, 3 and 4 in the scattered plots, on which days the difference between the high temperature and the low temperature is minimal. Difference between high and low temperature is minimum. Day 1 the approximate high temperature is 64, day 2 and approximately low temperature is 57, and the difference is 64 minus 57, 64 minus 57, otherwise it is 7 degrees, otherwise it is 7 degrees. Day 2 it is 76 minus 60, it is 16. So he wanted the difference between high and low temperature is minimum. So second day it is more than first day. So now till now whatever we have done, day 1 should be least. So let us go for day 3. Day 3 you are getting 82 minus 67, which is 15 degrees, which is higher than first option, and here you are getting 11 degrees. So answer is only day 1 children, okay. So please note it fast, quick. So again you should go for graphs only children. If you have to find out the same graph, you should check. We cannot help it, because graph is here, as these are questions from 6 to 8, 6 to 8. So even for 8th question also graph is same. So I have to go up and see, because already have taken a screenshot. It is you who have to check and then let me know, okay children. So we are closing it using approximate values. So this is done. So now we should do this, okay. Please note it fast, quick. We will go to the next page also, so that you should understand why day 1 is minimal. Right children, this is day 1. You should just note this children. Day 1 high temperature, low temperature, difference. Only these points you should note. High temperature, low temperature, difference. Please note only this, not all, not day 1, day 2, like this. Quick children. Right children, let us go to the next page. Again day 3, high temperature, low temperature, difference. Next day 4, high temperature, low temperature and difference. So these 3 you note, so answer you will get it as day 1. Right children, quick fast. Please copy it quickly. So right children, so let us go to the next question. Number of hours worked by the 20 salespersons in company G. Number of hours worked, number of salesperson. So 30, 34, 40, these are the number of hours worked. So 3 salespersons, here 5 salespersons, here 9 salespersons, here 2 salespersons and here it is 1 salesperson. Okay children. So let us observe what happens. 20 salespersons in company G. Okay. So this is 3 plus 5, 8, 8 plus 9, 17, 17 plus 2, 19, 19 plus 1, 20. Okay. Add all the working hours, you will get that. I mean, all the salespersons, you will get number of working hours. Okay. So now, based on the histogram diagram, what is the average number of hours worked by 20 persons? See, total number of hours worked by 20. If you do, you will get average number of working hours. Children, right? So 3 people worked for 30 hours. You see, again we should go back to that. 3 people worked for 30. 5 people work for 34 hours, 9 people work for 40, 2 people work for 45 and 1 person for 50. So, we will take the total values, means number of persons into number of working hours, like that. See, 3 people into 30, 90, 5 into 34, 9 into 40, 2 into 45, 1 into 50. So, total numbers of hours they worked is total hours by total number of people. Total hours is, I told, 3 into 30, 5 into 34, 9 into 40, like that. This type of problem we have done before also, but there is some other concept. This is some other concept by 20. So, you will get 760 by 38, that is equal to, I mean by 20, that is equal to 38, which is option C children. Okay. Please note from the previous page, from here, quick. Right children, so let us go to the next question. So of course next page, sorry, not next question, please note it fast, quick. Okay children, so let us go to the next question. Which of the following slopes is the closest to the slope of the line best fit for the scattered plots below? Which of the following slopes is the closest to the slope of line of best fit for the scattered plots below? So answers are given as 3. I don't know where is, yeah, here he has given best line of best fit. Line of best fit is slope y2 minus y1 by x2 minus x1. See, if you take this, so this is x2 minus x1 you will get. Similarly, you will be getting y2 minus y1. This is y2, this is y1, this is x2, this is x1. So y2 minus y1 by x2 minus x1. So that is the thing. So we have certain points on the thing. So here it is 1, so 2. So what is this is one point, and other point here we can take. So this is approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X2 is 11 and x1 is 1, 2, 3, 4. Like that, any 2 points you take to get the slope y2 minus y1 by x2 minus x1 we need to take. So this line has a negative slope. Why it has negative slope? Because it is decreasing, children. If it is increasing, it will have positive slope. If it is decreasing, it will have negative slope, because it is a decreasing curve like this. It is decreasing curve. So whenever it is decreasing curve, y2 minus y1 is negative and x2 minus x1 is positive. So negative by positive is negative. Therefore, it is negative slope. Since it decreases, this we have already discussed about minus 1. He says why it is minus 1, because 1 unit horizontally from the point 0 to 1. So 0 to 1. So you can take so 0 means it is best fit. So somewhere it should touch that, or you take anywhere. So y2 minus y1 you take anywhere for 1 unit. So you are getting minus 1 as the slope. So therefore, answer should be what? Minus 1, option D. Please note it fast quickly. So this page you take enough, not the previous page, not necessary. This has everything. Okay, please note it fast. I'll do one thing. Instead of drawing so many points, I'll take any 2 points. Yeah. So now look at this. Some 2 points you take. So this is 1 and this is 2. So this is 1 unit. So what is difference? So 1, 2, 3, 3, and this is 1 unit, and y2 minus y1 is 1 unit, 2 and 1, right children? So therefore, y2 minus y1 is 3 minus 2 by x2 minus x1 is minus 1. So this is x2 is this, sorry, minus 2 and 3. So this is x2 minus x1 is positive. So this is minus 1 by 1, that is minus 1. Please note it fast, quick children. So right children, so let us go to the next question. The scattered plot below depicts the relationship between two variables x and y. Which of the following best describes the line that best fits the data in the scattered plots? So, data in the scattered plots means you need to have this line of best fit. This is here. So, A, the slope of the line of the best fit is -3. You take any 2 points, children. So, this is x1 and y1 is approximately 2, if I am right. So, straight, okay. So, this is x2, and y2 is what? Approximately it is going up to I don't know, maybe little bit this side and that side. So, the value should be that. So, slope of the best fit is -3, he says. Clearly it cannot be -3. Clearly it cannot be -3. Therefore, let us not take it as -3. It is wrong. Option A appears to be wrong. Slope of the line best fit is 1, he says. No, it is moving upward, so it is rising curve. So, slope is positive. So, definitely it cannot be -1, it cannot be -3. So, they are ruled out. 0 it is not possible, because 0 means it should be horizontal line. So, option is D, sorry, option is D. Right, children? Why I am eliminating option 1 and 2? As it is a rising curve, its slope is positive. Therefore, 1 and 2 are, A and B are deleted. C is 0 means it should be a horizontal line. It is not horizontal line. So, only option left over is D. So, I do not even solve these type of problems, simply we will write orally. Okay? Please note it, children. Quick. First you should take the graph now. Please take the graph quickly. So, right, children, so let us go to the next page. So, this is the thing, please note it fast so that we go to the next question. See, children, like this problem, we do not need to solve, just analyze and then get it finished, quick. So, right, children, so let us go to the next question. Look at this, below is the scattered plot depicting the relationship between the variable A and the variable B. Which of the following best fit describes the relationship predicted in the graph? So, this is the scattered plot. Again, best fit line is not there. There is strong positive correlation between two variables. There is strong negative correlation between two variables. If it is increasing, it is positive correlation, decreasing, it is negative correlation. The two variables are not correlated, 0. As the value of A increases, the value of B increases. So, look at this. So, any values you take, this is horizontally, there is nothing. Below is the scatter plot depicting the relations between the two variables A and B. So, if you take so these two values, if you take, it is actually a negative. Everywhere you take, it is going to be negative only. So, points of the scatter plot appear to be randomly arranged in the graph. There is no indication that the values of A and B are not correlated. There is an indication that the values of A and B are not correlated. See, it's so haphazard. See, it's so haphazard, children. If you take these scattered plots, you see they are organized, well organized, not this scattered as they are. So in this they are very haphazardly arranged. They are very haphazardly arranged. Now I take these two, then it is increasing. If you take these two, this is decreasing. So as x increases, y also increased. Here as x increases, y decreases. So there is no proper relation here. Everywhere it is very haphazard. Therefore they are not correlated. They are not correlated. So option C satisfies more. Please note it fast, quick. Right, children, so let us go to the next question. Dollar value of the stock and the year. Dollar value of the stock and the year. The graph above shows how the value of a stock has increased over time. The line of the best fit shown. This is the line of best fit. Okay, children, the graph above shows the value of stock which has increased year by year. So as year increases, stock also has increased because it is an increasing line. If it is decreasing line, stock would have decreased. Okay. So now value of stock increased from June 2000 to June 2005 by approximately what percentage? So 2000 to 2005. So here if you take 2000, this is the value. So this is approximately 110, 20, 40, 60, 80. No, so 25 units. This is 125 units. June 2005, this is the point. So this is somewhere here. So this is 150. Okay. So what percentage it has increased means increased by original into 100. Okay. So June 2005 to 2000 it is increased by original is 2000 value into 100. So increase is 150 minus 125 by original is 125 into 100. So 25 by 125 into 100 means it is 20%. Right, children? Please note it fast, quick. So option is B. Quick. Please, you have to note the previous page also, isn't it? So please note it fast. So please take this screenshot. We cannot write. So take screenshot, children, quick. So shall we go to the next page? I think these are simple graph observations. I don't think you need to copy all these, children. When you practice, it's simple horizontal line, vertical lines, touch the best fit line and then take the values, that's all. So this you can note, which is 20%, quickly. Okay, children, so let us go to the next question. So what is the average yearly increase in the value of stock? What is the average yearly increase in the value of stock? So we need to take 2000 to 2005 by 5 years. So that is average increase, isn't it? So 150 minus 125 is 25 by 5, that is $5. Annual increase is $5. Quick. So copy it, children, fast so that we can try to do one more question. Okay, children, so let us go to the next question. What is the greatest difference between the actual value of the stock and the value of stock predicted by the line of best fit. The greatest difference occurred in June 2010. Predicted value is 170 minus actual value is 75 in June 2010. So that is 95. So look at this, what is predicted value and what is June 2010 you take. June 2010. This is the thing. So what is actual value? 175. Predicted value is somewhere below 100. So actual value is 170 sorry, and minus below 100. You see, I will show you how it is below 100. So predicted value is this is predicted value. Okay, this is approximately because we are only getting approximations, not exact values. So therefore that two values difference is this. Right, children? 170 minus 75, which is 95. The difference is 95 sorry, which is option D. Okay. Okay, children, with this we close here today's class. See, everywhere you have seen only we are drawing horizontal line, vertical line and getting the values and then doing what he is asking. All others are standard formulae what we have done till now, and you need to remember those formulae. We have not used any new formulas. We have used only the previous formulas like difference, percentage, means difference by original into 100, like that. All simple standard formulas only we use nothing new. So you just need to analyze, draw a horizontal line, vertical line and get the values. That's all. Okay, children. So we will continue in the next class. Thank you and have a great time.